My name is Iqbal Khan. I'm a technology evangelist at Alachisoft. Alachisoft is a software company based in San Francisco area, and I give talks. I'm a technology evangelist. So we have a main product called NCache. It's been in this space for a long time, and we've recently launched a NOSDB, which is a .NET NoSQL database. All of these are open source products, Apache 2.0. They also have an enterprise edition. So if you guys don't have the money or don't have the budget, go with the open source. But if your project is important, go with the enterprise edition. So
NCache is also open source?
NCache is also open source, right here. Open source. Everything is Apache 2.0. Let me actually, if we were to go to we got one more minute. So you can download Enterprise Edition. You can also download the Cloud Edition. You can download the open source edition from here, or you can go to GitHub, and you will see NCache here. NCache has been in this space for over 10 years, so it's a very stable and mature product with lots of people using it. Mainly in the US and Europe. Okay. I think it's 10 o'clock, so is everything okay, Nick?
Yeah.
Okay. Okay. Thank you, everybody, for coming. For those of you who just joined me, my name is Iqbal Khan. I'm a technology evangelist at Alachisoft. And today I will be talking about how you can scale .NET applications with distributed caching. I'm going to use NCache as an example, but this talk is not about NCache, it's about caching in general. So let me get started. I'll define a few terminologies, which I'm sure you guys know already, but just for completeness purposes. So the first terminology is scalability. What is scalability? It is high application performance under peak loads. So if you have an application with only 5 users and it performs super fast, it's not necessarily scalable. If it doesn't perform with 5 users, then you have other problems. But a lot of applications do perform quite well under 5 users. But when you go up to 5,000 or 50,000 users, suddenly things start to choke. So if your application does not choke, it gives the same performance, then it is scalable. And that's the goal. That's the whole purpose of this talk, is to show you how you can achieve that. Linear scalability is more of an infrastructure term. If you have a server farm of application servers and you max out, let's say if you had 4 servers, you max out with 4. And if you add a 5th one, if you can get an incremental benefit of a linear scale, then your application is scalable in a linear fashion. Otherwise, it is not. And most applications that are not using caching are not linearly scalable. So what happens, they have more of a logarithmic curve, which is, for those of you who still remember their college math or high school math, it's like a bell curve going down, like this and then like this. So that means that after a certain number of servers, if you add more servers, it's going to make no improvements. It's going to slow things down because the problem is not at that server level. I would prefer to keep this a more interactive discussion. So as I'm talking, if you have any questions, please raise your hand, and so we can talk about it right at that time. So which applications need scalability? These are mainly server applications. These are web applications, ASP.NET, or you could have Node.js or others. These are web services, again, mostly .NET web services, but other applications also. And if you have the backend for IoT, which are also usually web services, but just wanted to mention that as another major use case these days. Or if you have big data processing. Big data processing is not very commonly done in .NET yet. It's more of a Java thing still, but you can do it in .NET also. So big data processing is also another use case for scalability. And any other server applications that you might have. A lot of financial institutions, for example, have server applications that need to process a lot of batch thing. For example, all the customers that have updated their addresses, they have to have those applied, or all the funds that have to be transferred have to be done before next morning. So they have a deadline within which they have to get things done, and if they have millions of those requests, they need to be able to scale. So, what is the problem that we are talking about? The scalability problem. What is that problem? First of all, you must know that application tier, which is, most of these web applications are deployed in a load balanced web farm. The application tier has no problems. It usually scales very nicely. It's the data storage that has the bottleneck. And when I say the word data storage, it is relational databases, it is your legacy mainframe data. The NoSQL movement started partly for this reason, partly for the flexibility of the schema. But NoSQL databases do scale, but they're not all. I've skipped the word always here. They're not always the answer. Even though we have our own NoSQL database, they're not always the answer. Why? Can anybody say why NoSQL databases are not always the answer? Basically, if you're not able to, because they want you to move away from relational into NoSQL, which for most people is just not possible for a variety of technical and business reasons. So if you can't even move to a database, how is it going to help you? Now you can move some of the data, definitely. A lot of the non-business data, non-sensitive data, you can move, and that's where NoSQL is really thriving. But your customers, your accounts, your activities are all going into a relational for transactional purposes, for integration with other third-party systems, for a lot of reporting, for just a host of reasons why you cannot move away from relational databases. So relational databases are here to stay. You have to live with them, whether you like it or not. So they're trying to make improvements. There are a lot of in-memory caching within databases, but that's only improving performance. The fundamental problem with relational databases is that you cannot scale them in the same fashion as the application tier. So you could have an application tier, for example, with 50 or 100 servers. Most people don't. Most people have maybe 5 or 10 servers in the application tier. But you cannot have that many servers in the database tier. Database is going to have 1 or 2 servers. So when you have 10 or 15 or 20 servers in the application tier versus only 1 in the database, guess where the bottleneck is going to be? So the solution obviously is, since you have to live with the relational or legacy, you should use an in-memory distributed cache. NCache is one of those caches. There's also Redis from Redis Labs that Microsoft is promoting on Azure. But a distributed cache is the solution to this problem. It allows you to continue working with relational databases, with your legacy data, without having the scalability problems. So how does it achieve that? If you look at this diagram, it's sort of a deployment picture in a production environment. So you have a bunch of servers in the application tier. There's usually a load balancer here for some of these, not all. These servers may not have load balancers. But you can add more servers here. You cannot add servers here. NoSQL, yes, you can, but as I mentioned, you can't move the entire data set to the NoSQL database. So this caching tier is what you put in between the application tier and the database. And the cache, a distributed cache, is not like a standalone in-proc cache. A lot of you might have used the ASP.NET Cache object, which is a standalone in-proc cache. It lives within your application process. It's super fast, of course, because the entire cache is on your heap, but it doesn't scale. It's got lots of other issues. And the distributed cache is really an out-of-process cache. It sits within its own set of processes, or usually its own set of servers. These are usually Windows VMs in case of NCache. In case of Redis, these are usually Linux servers. But the goal is to trap about 80% of your traffic, or not trap, to go 80% of the time go to the cache, and about 20% of the time go to the database. And that suddenly reduces a lot of pressure off of your database and makes your database run faster for even updates, because it doesn't have to do a lot of reads. and the reads are super fast there. A caching tier, you got to have a minimum of 2 cache servers for redundancy purposes. And usually there's about 4-to-1 or 5-to-1 ratio between the application tier and the caching tier. A typical cache server configuration that we've seen is it's a dual CPU quad core, 16 gig or more RAM. So RAM is where the real key is, and also the network cards. So a typical network card is 1 gigabit or 10 gigabit these days. So, because the 3 things that become a bottleneck is memory, CPU, and network card. And that's what you need to scale by adding more servers. A typical cache server is not a very high-end machine. In fact, it should not be. It should not be a 256 gig memory, 64 core box, because then it's just like a database. The more memory you put, the faster the CPU has to be, because if you have more memory, you have more garbage collection, and .NET garbage collection is not cheap. It's pretty costly. So usually what we've seen is 16 to 32 gig is a common range, and with that you can easily live with 2 CPU quad core type of a combination, about 8 cores. But if you're going to go with 128 gig, then you should have slightly more CPU power. Any questions up until now? This picture is slightly misleading. It implies that you have to always go through the cache to the database, which is not true. That's only one of the paradigms, and I'll talk about both the paradigms. One paradigm is that you go through the cache, which is called the read-through model. You ask the cache for data, and the cache, if it has it, it gives it back. Otherwise, it calls a read-through handler, which goes to the database. The second paradigm is where you keep the cache on the side here. The application goes to the cache. If it doesn't find the data, it goes to the database, gets it, and puts it in the cache. Both models they have their own benefits, and I'll talk about those. Okay. And here's our typical cache scalability numbers. These are NCache numbers. For example, if you have a 2-server cluster, you'll do about 50,000 reads per second, about 32,000 writes per second. This is between the 2 servers. So that's the capacity of a 2-server cluster. 1K is the object size in this benchmark. This is usually, most of our customers have performance faster than this, because these benchmarks were taken within our own QA lab, which was a very high end. And as you can see, both the reads and the writes linearly scale. The writes are slightly slower because there's replication happening. If you turn off replication, then the writes are almost as fast as the reads. Okay, so the goal of the talk this much was to kind of convince you that you need caching. If you have a high traffic application, you need caching. Otherwise, you're going to have problems. And the problems usually occur in the worst time, and that is when you have a lot of activity, a lot of customers coming to your website, and if that website if your back end starts to slow down, your customers, you lose business. So the cost to the business is very high at that time. So it's better to plan ahead. So you need caching at that time. In fact, just to say one more thing, I forgot to say that. In-memory is the way of the future for scalability. It's not just distributed caching. A lot of databases are also going to in-memory. And that's because memory has proven to be just so much faster than any other storage that has been invented so far. And you can do so much with an in-memory store that you cannot do with a persistent store. And I'll come back to this also. Caching is really becoming more of a new best practice in a lot of companies, where they build a caching infrastructure, and every application now has this available as another data store in memory, where they can either cache data that is coming from database or store other transient data. And I'll talk about that too. So now that, let's say, we're convinced about the fact that you should use caching, what are the ways that you can use caching? What are the different use cases? Where do you use caching? So there are 3 different areas that we've seen over the years. The most common, of course, is the application data caching. That's what I've been talking about up until now, where you have a database, you cache whatever data you get from the database, you cache it, and the next time you'll find it in the database. So, and the goal, as I mentioned, is to reduce that database traffic so that you can go into a faster and more scalable store. The thing to keep in mind in an application data caching is that the data exists in two places, in the cache and the database. So when a data exists in two places, what's the first problem that comes to mind? Concurrency. And what would happen? Synchronization. If things went bad. So the cache must always be fresh, must always be consistent with the database. Any cache that does not give you that assurance, it forces you to cache read-only data, lookup tables. And lookup tables and read-only data is probably 10-20% of your total cache. 70 or 80-90% of the cache is what we call transactional data. These are your customers, your accounts, the activities. And most of that data, when you cache, whatever data you fetch, you will most likely need it again in the next few seconds. Because within that user activity, or even by other users, you will need that. So this is the problem that any cache that is supporting application data caching must support. And we'll come back to this. Just want you to keep that in mind. And the application data caching is with permanent data. Permanent data means this data exists in your database. So it's always there permanently. And only a copy of it is kept in the cache. The second common use case is if you have ASP.NET applications, and this is true for other web applications too, but I'm sticking to ASP.NET, there are three things that you can cache from within ASP.NET. Sessions. If you're not using the MVC framework, ViewState. ViewState is going away slowly, but there's a lot of applications that still are pre-MVC. And ASP.NET Output Cache. Output Cache is the page output that gets cached, so the next time the same page gets called and the content of that or the output of that page is not likely to change, why execute the page? So this is a framework that Microsoft ASP.NET gives that you can cache. So those are the three things that you can cache from ASP.NET. Now the thing that to keep in mind is this is transient data. Transient means temporary. And the data exists only in the cache. So when the data exists only in the cache, what is the first problem that comes to mind that what could go wrong?
You don't know when to flush it out. You don't know when to flush it out of the cache. You don't know when to make it expire.
You may lose the data actually because because cache is in memory. Memory is not persistent. It's not a stable storage. So if for some reason that server restarted, you're going to lose that entire cache. And if this was your, let's say, shopping basket, I'm just saying, and you're an airline or something where that purchase may be a few $1,000s, and on the last page, right before the customer hits submit, his session state is lost, and he has to start all over again. Not a very good experience, for that customer. You may lose that customer. So the most important thing in this case, other than performance and scalability, is that the cache has to ensure that the data is not lost. And the cache ensures that through replication. Because it's not a persistent store, it has to replicate data across multiple servers. And I'll talk about that too. A third use case is something that a lot of people don't know, which is that caching or distributed cache, because it's a cluster in your infrastructure, and it's an in-memory and super fast cluster, it can be used for a lot of the runtime data sharing that you traditionally did with message queues. Now, it is not a replacement of message queue in all situations because message queues have other purposes where they persist data and they guarantee across different locations. But if most of the data sharing is within the same data center, which is what it happens most of the time, you have a workflow application, one application produces something, it needs to feed to the other application. Usually you store all of that in the database and the other application keeps polling the database and then once it consumes it, it removes it from the database. So that's not a very good model. Message queues are also not as suitable as a distributed cache because they're not as scalable. They're not as fast and not as scalable. Their whole architecture was not for this purpose. It was for a different purpose. So Runtime data sharing through events is a very, very powerful feature that a good distributed cache provides you. NCache has it. Redis also gives you this feature, although NCache has more capabilities in this, but at least you can use both of these. So event-driven data sharing in a pub-sub model, event notifications, and continuous query feature. So runtime data sharing is also like the ASP.NET. It is a transient data. Some of that data may exist in the database also, but the form in which you're sharing it is probably transient, because you're sharing it in a form that is to be consumed by another application. So again, the same sensitivity. You cannot lose that data. Replication is a must. So those are the three common ways that people can benefit. How many people here have ASP.NET applications? Quite a bit. Yeah, good. So I think if you have an ASP.NET application, all three use cases would apply. Two definitely, and the third one also you should think about. You must have a lot of back-end situation. For example, we have this one customer. It's a large bank, and they have a corporate bank wire application where it's a workflow where one part, the wire gets submitted, and the other parts have to pick it up and process the wire. And each wire is a lot of money. It's a business wire, so it could be millions of dollars, and that each wire data is being stored in the cache. And they're confident, well, as I said, in that shape it is being stored in the wire. There's a permanent data behind it which could be used to reconstruct it. But they use it in the cache because the cache replicates it, and they can do it in a much faster because they have that throughput issue. They have to process that many wires in a specific calendar day, or they have a contractual obligation to do so. So a lot of those things, scalability is met through that as well.
What's the continuous query?
Continuous query is like it's like a SQL dependency feature of SQL Server. Has anybody seen that feature, SQL dependency? Okay.
It's like when cache refreshes itself when SQL Server changes?
Exactly. So basically, what it is that you specify an SQL statement. You say, select customers where customer.city is New York. And you say to the cache, monitor this data set. If any customer with this criteria is added, updated, or deleted from the cache, notify me. So you are able to monitor changes based on a criteria. That's what SQL dependency does to a database. It says to the database, notify me if any rows in this data set are added, updated, or removed. Except this is not on a database, it's on the cache. It's much more scalable because of the fact that it's distributed. And again, the runtime data sharing really needs these type of things because you're watching for somebody else to produce data or update data, and as soon as that happens, then you pick it up and do your own processing. That's the use case where runtime data sharing comes, whether it's pub/sub or it's just other event notifications or continuous query. Any questions?
I mean, I don't know if it's the right time to ask this question, but you're saying there is a way with NCache so that you do your inserts, updates through the cache to data.
Yes, I'll come to that, and I'll talk about the benefits of doing that. That's a very important question. Okay, so let's go into what does application data caching look like. I'll actually show you much more code than this, but a typical, you've got a load customer. Before you go to the database, you check the cache. You have a key. The key is usually like the type name, the attribute name, and the value. This is just a convention. You can come up with your own conventions. But a key needs to be unique for that object. If it's not in the cache, then you go and get it from the database and put it in the cache. When you do that, the next time either you or anybody else wants that customer, it'll find it in the cache. Very simple concept. Is
it threat safe?
Yes. So the cache itself all methods are threat safe. So you don't have to do any of your own locking. So you just make the call and cache will take care of it. In fact, cache does a lot more than that because the actual data is probably sitting on another server and being accessed by multiple clients from different boxes. So it has to also make sure that even there it's all concurrent. So it does a lot of read-write locking and make sure that you get the correct version of the data. What does a cache API look like? this is very similar to the ASP.NET cache object. I'm showing you the NCache API. So you connect to a cache. Every cache has a name. So, and let me quickly show you what the cache looks like before I go into, because then there's a lot more coding. So I have this. So I actually have a few VMs on Azure that I've started NCache on. So these two, demo 1 and 2, are going to be my cache servers, and demo client is going to be my client. Client is your application server box. In reality, you will have a lot more application servers than the cache servers. So I'm going to log into the, I've just logged into the demo client, or I thought I did. I'm going to use NCache Manager, which is a graphical tool, and I will quickly show you how you can create your cache. So again, think of it that this is your production environment and you want to create a 2-server cache cluster. I'm going to come here and say create a new clustered cache. All cache clusters, or all caches, are named, so I'll name mine demo cache. I'll say keep the data in a binary format instead of object format. Binary is what you need for most of these web applications. Object form is what you need for big data processing, and I'll talk about that also. I will pick a caching topology. I'll just pick partition replica. I'll talk about the topologies. All caches have to support different topologies, and NCache gives you 4. So, and I'll stick with the default asynchronous replication. I can also pick synchronous. So if you have sensitive data where you don't want any asynchronous, you want to make sure that when the cache tells you that data is updated, it's actually updated in 2 places. Then you pick the synchronous. It's slightly slower, but but most people pick async. I will specify my first cache server here. I'll specify my second cache server. Again, very straightforward. All these things that you're doing with NCache Manager, you can also do it through command line tools, so that you can script them for production or for other. Oh, I have the cache already. Let me just go ahead and remove this. And this is a pretty loud. Okay, so I will go ahead and do the same thing again. Demo 1, demo 2. I'll take all the default. I'm not going to go into details of that because the purpose is not to teach you NCache. The purpose is to show you what a cache looks like. You can specify how much memory the cache should consume. This is an important feature. Any good cache should give you that ability, and I think Redis also does give you that ability, but NCache definitely does. So you can specify here's how much memory NCache should use. When NCache consumes that much memory, cache is considered full. When cache is full, then 1 or 2 things will happen. Either NCache will start evicting some of the existing items, and you can pick the algorithm. So let's say you'll say least recently used is a very popular algorithm. Or you can say turn off eviction, in which case NCache will reject any new additions. So most people just stick with eviction with on. Although, for example, for sessions, you never want to evict. You want to always expire the sessions. But I'll talk about that too. I will go ahead and add one of the clients, which is my demo client. And I've got lots of features here. So I'm just going to go ahead and start the cache. So that's how long it takes you to create a cache cluster. And of course, this is the client. As soon as you add a client, assuming that you have installed the client portion of NCache software on all those boxes, NCache actually comes here and modifies this config file, client.config. So as you can see, it just created an entry here called demo cache. That way your application, when your application connects to the cache based on a cache name, where was that? Based on a cache name, it goes into this file, looks for that cache name, and picks one of the cache servers to connect to. Then once it connects to any one, that it learns about all the others. So it doesn't need to know about all of them in the config. But just, okay, I will go ahead and say view statistics. These are perfmon counters. And I'm going to also say view NCache monitor, which is just to monitor the cluster. So, and now I'm going to come here and do this. NCache comes with this tool called stress test tool. So if I run this, it just lets you test the cache and also put stress in it in your own environment. You'll see that this tool is talking to both the cache nodes and is doing a bunch of activities. So I'm doing about 500 to 600 requests per second on each box. Let's say I want to increase that load, so I'm going to launch one more instance of it. And now I'm going to increase mine to about, as you can see, about 12 to 1500. So as I keep adding more and more load, you can see this stress. So you can very easily see how fast NCache is going to perform in your environment based on your own application needs. And that takes away all the risk, because you don't have to commit to NCache unless you see that it performs based on your needs. And of course, let's say if you maxed out these two servers, all you do is you say add a node, add runtime. I don't have a third node here, but if I did, I would just say, let's say demo 3, and it would just add it. And it would automatically adjust, it will automatically shift some of the data from existing partition into the new one, do the replication. Everything is done all automatically. And suddenly I have more capacity.
Does that require all the clients to be updated with the definition of the new server that was added, or
no?
Just adding it in allow?
Yeah, so all the clients are notified in memory.
Okay.
So but once a client connects to any one server, it gets the membership of all the cluster. And when that membership changes, the new membership is sent to all the clients, all at runtime. So that's something that is very, very, for NCache, it's very important that it's highly available, which means that you can't bring it down just because you're adding a new server.
Can I ask a follow-up question? So, so I assume like this configuration we're doing right now is more of like a mirror cache, so we can suffer the loss of one of the servers and still be able to, respond to client requests.
Right.
Is there another model that allows the larger amounts of data to be distributed amongst the cache and shared between them, so that maybe we need 3 of the servers to be online in order to have a complete set of that cache?
Right. In case of NCache, it supports 4 topologies. The first is called mirrored cache, in which you only have 2. So there's an active and passive. We didn't use that one because you just talk to the first server, and then if this one goes down, the passive becomes active.
Okay.
The second one is called replicated, where you can have more than 2 servers, but every server has the entire copy of the cache.
Okay.
It doesn't scale in terms of storage. It scales in terms of read operations. The updates are not as fast because they have to be done synchronously on all. The third is partition cache. That's where you can have as many servers you want. Every server has one partition. And the fourth is partition replica. That's what we used. So you can have as many servers as you want. Every server has one partition. And every server's partition is backed up onto a different server. So that's the replica. It's just like the RAID disk technique. You can add more servers, and the partitions are automatically readjusted. So there are about like 1,000 buckets that NCache cluster creates. Depending on how many partitions you have, it has 1/nth of the buckets. And the buckets can be shipped from one to the other. For example, there's a feature called data balancing.
At runtime? So
At run, everything is at runtime.
Servers and things start
Everything is at runtime.
Okay.
So there's nothing that you have to stop or configure. NCache does it all for you. So as you add a third server, the third partition is automatically created, and the replicas are automatically readjusted. And same way, if you had 3 partitions and you drop one, automatically everything moves to 2 partitions.
So does that mean there is absolutely no downtime whatsoever?
There's absolutely no downtime whatsoever. NCache has been in this space for more than 10 years. We have customers that have it running for years. NCache also gives you live upgrade features. So you can actually, for example, especially in a larger company, you have applications that need to constantly upgrade themselves, right? So you do bug fixing or new features, especially business application, pretty much every few months you have to do it. So NCache allows you to keep a mix of the old and the new, especially, and also when you want to upgrade NCache versions, the clients can be upgraded first. So let's say you're not ready to upgrade the server yet, so you would upgrade the clients. Some of the clients are older versions, some of the clients are newer version, and they'll both work with the same cache. Now NCache also has a feature where you can upgrade the cluster live. So you can bring some of the nodes down and upgrade them, and then bring them back up and then upgrade the other ones. So some of our customers, because again, a lot of these web applications are what I call e-commerce. That means online business. Online business cannot go down. I mean, we've got customers. Let's say we have a large airline customer in Europe. If they are down for half an hour, they probably lose $1 million, or more. So, you can't afford to do that. So the sensitivity is very, very high, and this is where NCache really shines. Okay.
From an installation perspective, are those Windows services?
These are all Windows. Just purely, so you get MSI, Windows installer that you install either through scripting or through manual, and all the caches are run in Windows service process.
So there's no IS involved?
There's no IS involved. NCache has its own processes. Because IS actually is quite volatile. It recycles quite a bit. And by the way, the clients actually connect to the cache and stay connected. Unlike HTTP, where every time you do a request, it's a new connection. Here, the clients stay connected. Every client connects to all the servers in the cluster, in case of partitioned cache, and that way they can go directly where the data is.
And the client API is just a NuGet package.
It can be, yes, it can be. So if you were to, for example, come here and go to the download NCache, you can also download where's the NuGet? There.
So that's
Yeah.
the preferred way?
Yeah, a lot of people just do that. Any questions?
Can we have a different eviction policy? Say I want to last in least used on one side, and the other policy for the other one.
Within one cache, you have one policy, but you can have multiple caches on the same servers. So on those two servers that I showed you, I could create 2 more caches. Every cache will have its own eviction policy. But eviction is only when the cache is full. Let me now come back to where I wanted to show you guys about. So what is it that you need to do when you're doing application data caching? So the first thing that you need to ensure is that the cache stays fresh. As we talked about, it's in 2 places. So how do you ensure that cache stays fresh? Number 1 is expiration. Expiration is what you want to use instead of eviction. Eviction is only to handle sort of unforeseen capacity. You didn't plan, you couldn't estimate all the capacity, so suddenly the cache is full, so it's good to evict than to reject. But most of the time you should use expiration. So there are 2 types of expiration that NCache supports. One is absolute, the other is sliding. Absolute is for permanent data. Absolute says, when you're adding the item to the cache, let me just show you that in the code. So if I were to come here, I've got some basic operations. So here's a typical .NET project. So you'll have a bunch of .NET assemblies, ncache.runtime, ncache.web. And you'll use a bunch of namespaces, so ncache.runtime, ncache.web.caching. So web.caching is the main space. And we've tried to keep it as close to the ASP.NET cache naming convention, because when we came out 10, 11 years ago, that was the only thing available. So you connect with the cache, you got a cache handle. Then you create your object, and you say cache.add, right there. And you specify key, and you specify the actual object, and you specify, in this case, a date time. So the date time, it says just 1 minute. So add minutes means add 1 minute from now. So you're saying expire this 1 minute from now. So you're basically saying, I only feel comfortable caching it for 1 minute. I think if I cache it for longer than 1 minute, it's going to change in the database. That's what the goal is. So you're making a guess, and you're expiring things. So that's absolute expiration. Very important feature that you should use. Sliding expiration is more for transient data. You don't use it usually for permanent data, because sliding expiration says expire this when nobody's using it for this long. So either and use means fetch or update. And for example, ASP.NET sessions, when the user logs out, nobody's going to touch that session. So 20 minutes later, that session should be cleaned up. That's what the paradigm is. So the sliding expiration is more of a cleanup behavior that you use for transient data. I think it's really important to know that difference. Absolute expiration is for permanent data, and sliding expiration is for transient data. So that's one way to make sure that cache stays fresh. Second way is, let's say you can't predict when the data might change in the database. So you say, well, I want the cache to synchronize itself with the database. So the cache should become a database client. Whatever data I add to the cache, I will specify a mapping with that cached item, of that cached item with some data set in the database. And when that data changes in the data set, the cache should itself update. And update should either be that it removes that cache item, because once the item is removed, what happens? Next time you look for it, you don't find it. When you don't find it, you go to the database. You get it and you put it in the cache. That's one. Second, the cache maybe could reload a new copy of that data. Same thing goes with expirations. Expiration, if you have more of a lookup data, or if you want to keep that data in the cache as much as possible, so it's better not to remove on expiration. It's better to reload. So both of these reloading features for both expiration and synchronization can be done through the read-through model. And I'll talk about that in a bit. So the database synchronization is a way where the database sends an event to NCache. That's the SQL dependency I was talking about. So SQL Server has this feature called SQL dependency. You can do it against Oracle also. Both of these use database events. And if you don't use any of these two databases, you can use polling. But even with these two databases, you can use polling if you have a lot of data. SQL dependency, essentially, here's how it looks. Oops, I'm just gonna, there. So I've got this open here. Okay. So again, I'm going to connect to, so I will of course reference both of these assemblies, and I'm going to connect to the cache. I've got my cache handle, and now when I add something to the cache, right here, I want to specify a SQL Server dependency, which is basically, it's a connection string to your database, and it's a SQL statement. So you're saying select product ID, product name, quantity from products where product ID is whatever the product ID. So this is like one row of the product table. You in this example is right. You probably didn't even need to do all this. You could have just said get product ID only. But when you specify the SQL statement, you pass it to NCache through here, right here. As you can see, you cache item.dependency, SQL dependency, and when you're doing cache.add, you specify the cache item. So now you've just told NCache, here's my database connection string, here's the SQL statement. For this cache item, for this cache item, please map it to this data set in the database. So the cache, if you remember the cache, so there's a cache cluster, right? this cache cluster will become a client of the database. For this, it's gonna establish that connection and tell the database to please notify me when this row changes. When that row changes, NCache receives an event from database, and NCache can then either go and remove. The default behavior is it's going to go and remove that item from the cache. Removing means you no longer have an old copy. Or if you have read-through, then it'll call read-through to reload a new copy. Database synchronization is a very powerful feature. Again, you want to make sure that your cache can keep your data fresh. If it can, the more data you can keep fresh, the more data you'll cache. And transactional data really needs to stay fresh. Reference data, it depends on how frequently it's changing. It still may need, otherwise you'll have to do the bookkeeping yourself about when to remove it and when to reload it. What you want is to set it up once and have it always be correct. So SQL dependency is a great feature that you definitely want to use whenever you cannot predict how frequently or when is the data likely to change.
In that scenario, is it actually running a query against the database?
It actually, what it does, it actually, so if I were to say ADO.NET SQL dependency, it actually uses this feature of SQL Server, and this feature essentially means that when you issue that command, SQL Server monitors the database. SQL Server monitors your data, whatever data set you specified in the SQL statement. SQL Server is monitoring it, and SQL Server notifies you being NCache now.
So it depends on if the database supports it. If we're using Postgres and Oracle and SQL Server.
Yes. Okay. So SQL Server supports it, Oracle supports it, Postgres probably, I don't know if it does. If it doesn't, then you can use polling-based feature, which is NCache's own feature, where you can implement, it's a special table that you implement. It's a synchronization table. So for every cached item where you want the synchronization, there's a row gets added to this table. It has a flag or some number, and then you modify the database trigger to go and update that flag. And then NCache polls that table every, let's say, 15 seconds or so, and it fetches all the rows that have been updated, and it goes and invalidates or reloads those items in the cache. So even with other databases, you can do synchronization, and that's where the polling comes in. Polling is actually, even with SQL Server, polling is more efficient, because if you had, let's say, 100,000 items that you wanted to synchronize, for SQL Server, you'd have 100,000 SQL dependencies. So for every SQL dependency, SQL Server actually creates a data structure on the server end. So it's an overhead. So the more SQL dependencies you create, the slower the SQL Server performance is going to become. So at some stage, it becomes more efficient to say, okay, I'll take the hit. I'll wait for 5 seconds or 2 seconds or 3 seconds, and I'll just poll every few seconds. And NCache will poll, and polling is in one fetch you can get thousands of rows back, and then update the data, update the cache.
And so then does NCache pick which node is going to actually do the polling, or does it rotate through the nodes?
So NCache depends on caching topology. If it's a partition replica, which is what we use, every node polls. Every node. No, I'm sorry. Yes, if it's a partition replica, every node polls, or every node has its own SQL dependency created. If it's a replicated cache, only one of the nodes, because every node has the same copy, so only one of the node polls.
In that
Sorry. Go ahead.
in that example where you had the SQL, so I'm assuming it queries and then returns some kind of an object, right? That NCache builds on the fly to the data type of the data that's returned. It would be like a dynamic object that's...
Yeah, so basically NCache will use something like this, some code like this. It's going to call SQL dependency, and it needs to provide, I think, like a callback method to SQL, and or if I'm not mistaken, hold on.
So you can provide your own type to populate, right?
So NCache will make the SQL server call, the SQL dependency call, and the SQL dependency call will accept a callback which gets called by the SQL client. And that call passes the information back about what was the data set that changed and what was the change. And then NCache at that time will invalidate the corresponding cached item. Because it cannot assume that whatever changed is the entire cache item. It will always invalidate unless you do the read-through. So whenever it needs to reload a new copy, it does not do it automatically. It depends on your code to do so.
So the things that we are using the cache now, the SQL dependency, what's going to happen? In our application, we're using the caching already.
Right.
And if we put in this in there, what's going to happen to our application? You got to modify the whole thing to use the NCache.
Actually, so what you do is you do incremental upgrades. So the first thing that you do, whatever you're doing right now, just do as is move to NCache or something like NCache, and that gets you to a distributed cache paradigm, makes you scalable. Then you go to the next stage, which is, okay, now let me try to synchronize, let me cache more data, more time-sensitive data, and as I'm caching more and more data, I'm going to define how I want to keep it fresh. So for some data, I'm going to then specify this type of a SQL dependency, and then NCache will automatically ensure that it gets synchronized.
I know somewhere we do the cache locally, and somewhere they use SQL dependencies.
So what happened is, when people who were using ASP.NET, I think I'm assuming you've got ASP.NET Cache, right?
Yeah.
So since ASP.NET Cache is a standalone cache, what people did to try to use it, so improvise in a multi-server environment, is they were going through the SQL server to synchronize. So what they did is, let's say let's say that you've got two boxes here. Each of them have ASP.NET Cache. So you use SQL Server to synchronize. So use SQL dependency against SQL Server and say, notify me if this data changes. And that's how you synchronize. The problem is that you no longer are scalable. So the issue of scalability wasn't solved. And you put a lot more dependence on the application to do it. But this is why people had SQL dependencies to synchronize two copies of ASP.NET Cache through SQL Server themselves. See? So what we're saying is that the multiple copies of the cache gets synchronized by NCache itself, which is super fast, and it's only the data that you think that's time sensitive. Not all data is time sensitive. Some of it you should just do expiration. Expiration is a lot more efficient. Some of it you can do through polling, but it's only data that you cannot predict that is changing that you go through SQL dependency. And even there, the SQL dependency is happening between the caching tier and the database. So in your case, what you would do is you would remove all the SQL dependency calls and just put the cache calls, and NCache will. The API is almost identical to ASP.NET Cache, so your code change will be very minimal. Okay, let me just come back here. So we've talked about SQL dependency and DB dependency. Even DB dependency, if you have 1 million items in the cache, you don't want to have a table with 1 million rows with a flag as an index, because when a flag may have either 2 or 3 values possibly, and if you index those, that's 1 million divided by 3 is so that tree, that B tree or whatever the index tree is going to be very costly tree. So in those situations, it's better to do a CLR procedure. NCache lets you do that, where you basically write a CLR procedure. Let's say you've got a customer table, and you're saying every time a customer is updated, call this procedure from the trigger. So there's an update trigger on the customer table. It calls your CLR procedure, and the CLR procedure just makes an NCache call and says, please update this customer. Because the CLR procedure is your code, so it can pass your customer object back to NCache. And the only thing to keep in mind within CLR procedure is it's being called from within a database transaction. So you want to make async calls always, because otherwise, imagine you're updating 2 or 3 servers, and the database transaction will start to time out pretty soon. NCache provides async methods, so you can say cache.insert async, which it just immediately submits the request to the cache and comes back. Of course, if the update fails, then you will be notified, but that doesn't happen very frequently. So CLR procedure is a third way to synchronize the cache with the database. So synchronizing the cache with the database is a very, very important feature if your data is important, which is what it is if it's transactional. By definition, transactional data is something very time sensitive. You can't have it go wrong. And the same thing you can do with non-relational. So if you have other, go ahead.
Yeah, when you talk about the SQL dependency sync, I remember that in your code you have a query text, right?
Mm-hmm.
And then use this the object called it to run the query. Yeah. So this query is the original query, or is it like a customized query just for some particular columns that is often updated?
It does not have to be identical to the original query. It just needs to get the same data set back, the same rows back. So for example, the original query might have gotten 20 columns back because that's how you built your product object. But this one only needs one column back. It just needs the row. It just needs the fact that this row has changed. So as I was saying when I was explaining, you don't need to have all these columns in this. You just need the product ID is fine. Because you only need to know, okay, this was the row, let's say product ID 1000 was the one changed, and maybe you change the price, So you don't need to know what the new price is because NCache is not going to load that object at this time. It's going to call read through and then reload. But all NCache wants to know is did product ID 1000 change or not? If it did, go and remove it from the cache or reload a new copy. Did that answer your question?
Yeah.
Okay. Any other questions?
So like if I had something like, which we do in our entire database, every table has a DT, date time modified. So and that's populated automatically in the database. So that would be select product ID, date time. If that changed, anything in the row changes,
Yeah.
date time's going to change.
Yeah.
So that's all the query would have to be.
Actually, what all the query has to say is this row. You just need to specify the product ID, the primary key.
Okay.
And the SQL Server itself determines any column that changes. SQL Server knows this row has changed, and it will then notify NCache.
Okay.
So the only thing that you need in this query is a way to identify what that row is. Say, is it product ID 1000 or 1001, 1002? That's all. So all you're telling SQL Server, if this row changes, please notify me. It doesn't matter which column changed. Because all you're interested in is making sure that the cache is consistent. You don't know what changes were there, because you will know once you reload, because you just get everything back, but you don't care what changed. All you care is something changed.
And it knows that.
NCache will determine itself, any column that changes, NCache will fire the event. Or SQL will fire the event to NCache.
So there's no other polling mechanism though, where instead of it being rows, because I think it's piggybacking off of his question, where we also have a lot of modified on columns, where it can pull for a data set of items that may have changed since the last time that it checked, and invalidate maybe a bunch of them at the same time.
Now NCache has another feature called, and that's a cache updater. It's a separate service which calls your method on a polling interval, and then you do whatever you need in that method.
Say go invalidate these 25 items from the cache.
Exactly.
Okay.
So because you went to your data source, you determined that these were the keys that changed, and you tell NCache, please go and either yeah. So that's a much more customized situation. This one, NCache is directly talking to your database.
So in this model, just to confirm, in this model, you're storing any specific customer or product as a separate cache item?
Yes, so whatever the cache item represents in the database, that's what this SQL should say. Let's say if the cache item was based on a data set that came from 2 tables. So this SQL statement should have a join of 2 tables.
Right.
I think,
So
yeah.
the model is a single record to join per cache.
Actually, the model is whatever data set constructed that object. It could be a collection of rows. Because you may have a customer list. Let's say you have a customer list, all the customers in Philadelphia. I have 1,000 customers, let's say. So all those 1,000 customers are being cached as one item. I just cached the entire collection for whatever reason, right? So I don't want that to go stale. So I will say, I will specify the SQL statement where I say city equals Philadelphia, and even though that's a 1,000-row criteria, SQL Server is going to monitor it and will notify me if anything changed. So even if a new customer was added matching that criteria, SQL will notify me.
Refresh the entire set?
And then I will remove the entire set.
Right, okay.
And then once it gets removed, then, or I will call read through.
Okay.
So one of the two models.
So what's the data type of the object that's being cached? Is it a data set or like
It's any .NET object.
Yeah, but when we execute the SQL, I'm assuming it pulls some kind of it's using ADO.NET, right?
Yes. So what you do, you can cache anything that is serializable. So it could even be the data table can be. I think it is serializable now. It didn't used to be. I think. So you can cache those directly if you want. But a better practice is to transform those into your POCOs, your own domain objects, and cache domain objects.
But in this case, you're passing the query to it, and it will execute for you, right? The NCache will.
Only for monitoring purposes, not for fetching data.
I see, gotcha. Okay.
So you fetch the data already. So again, you have the product already. See?
Okay.
So from somewhere you've already gotten the product, probably from the database. But you're caching it now. And you're telling the cache, for this product, please establish the connection with the database just for monitoring purposes.
And you mentioned that there's an async interface, because technically that's an IO bound operation, right? It's a distributed cache we're hitting. So when we say add a cache add, that would be IO bound call, right?
So you could actually add this stuff to the cache asynchronously, in which case this entire, hold on. Yes, so you could do in cache.add async. Let me actually take you to, if I come on to our website.
Because we're crossing the process boundary in this case,
Yes,
right? So
yes. So let's say if I were to go to the .NET API reference here. Oops, not this. Web.caching. So if I do a cache class methods, so I could do an add async. Add async can take a cache item. Cache item means that yes, I can do all of that. So whatever I just did, I would just call add async, and it would submit that to NCache and come back immediately. And all the database connection will be happening asynchronously.
it's interesting because it doesn't return a task.
Because you do this. So there's a
So it's a callback.
It's a
not
callback.
It doesn't use the async. So how do we take advantage of like ASP.NET, async await in that case? Just I guess wait on the task to complete.
actually, I mean, you should use async only when you don't want to wait. If you're going to wait anyway, I mean, if you specify this callback, then the callback gets called and it runs in a separate thread and does whatever you need to do. But if your business logic says that you can't move to the next page until this is done, then you might as well just call standard cache.add.
You're telling them thread.
Yeah, so
Right.
you're not releasing.
Async await, you're releasing the thread back to the thread pool.
So if you have a million requests and they're waiting on the cache because it's distributed,
Right.
you kind of want to release that to the pool.
Right, and I think
In
so.
this case, you're not. You're going to be blocked, right?
No, because in this case, you will come back immediately, and this actually executes on a separate thread, because this is used by NCache. See, the NCache client,
Okay, yeah,
NCache
yeah, they should
client.
probably update that because it's not
Yeah.
fitting well into the model. Like
Okay, I'll pass that on to engineering. But basically, the callback is actually called by the NCache client API or the client, and that call is received when NCache client receives the notification from the database, which is already in a separate thread, and NCache makes the call to the callback in an async model. So it is all. So the NCache is highly multi-threaded. Everything is based on thread pool, so that we don't block.
But it's outside. It's pulling the thread outside of the request thread, so that means it still potentially could starve the site.
Right. Okay.
Question.
Any other questions?
When you sync the cache from the database, for example, if you already load the cache, like with the 10K records, and then at the same time some other applications is updating the database, and you need to sync that changes to your cache.
Right.
So is it by polling or by the?
So it could be one of these. So it could, if the data is already in the cache. So there are two types of updates. One is the data is already in the cache. So the most important update is the data is already in the cache, and you don't want it to go bad or stale. That's the most important. That's where you can use either SQL dependency or DB dependency or CLR procedure. Okay. The second is that you're just adding new data to the database, and you just want that data to be automatically pre-populated to the cache. So, for example, NCache has this feature, and I didn't have all those details here because it was not really about NCache. It was more about caching. But I'm more than happy to talk about NCache. So NCache has this feature called cache loader. So when you start the cache, it gets called. It can pre-populate the cache with all the data. Now we've also added another feature called cache updater, which is what I was talking about, which is something that you register and it gets called periodically by NCache to say, is there any more data to add or any data to update? So that goes and updates. So if you want to add new data automatically to the cache, you can use either cache loader, which is only on startup, or cache updater, which is automatic or periodically it gets called. But if you want it to be done real time, then CLR procedures could be used. So as you add data to the table, CLR procedure could be called, and it would go and update the cache. The only thing is that it would be called for every row separately, and you may want to wait and do a bulk operation.
Actually, that's my question, because if we have like several thousand K records, and you want them to be near real time, like replicated to your cache. So how these can be done?
If the data was already in the cache, you can use SQL dependency and it'll be done. If the data is not in the cache and on your main need is to add it real time in the cache, then you could. The cache updater is called every few seconds. So if a few seconds is okay, then that's going to be fine. But if it's not, then you have to write your own code to go and update the cache. I mean, you always have that option to write your own code. Whatever code is adding to the database also goes and makes the cache call. But these are more of convenience things that the more and more of the plumbing NCache will do for you.
Thanks.
Okay. Any other questions? I think it was a very good discussion.
How do the nodes talk to each other? Is it by TCP?
Yes. So basically, NCache forms a cache cluster, which is a TCP-based cluster. So if you see the cache cluster, it's our own TCP-based cluster. It's a dynamic clustering thing. We actually, back in 2004-05 timeframe, we took this framework from Java called JGroups. I don't know if you heard of JGroups. And we transformed it into C#. We kind of owned it. And that became the core of NCache clustering. So it's highly dynamic. It's a TCP-based architecture. Within the cache cluster, NCache has queue-based architecture, so it's super fast. And between the clients and the cache, also it's a TCP-based. It's a separate protocol than the cache cluster. The cache cluster has its own protocol, which is different from the clients. The clients is much lightweight. The cluster has got more.
So basically, they're all peer-to-peer. There's no like a primary or secondary. Or
There's no primary, secondary. It's all peer-to-peer. There is a concept of a primary coordinator, which is the oldest node. But if it goes down, then the next oldest automatically becomes.
Just a follow-up to that, then, if you have like 5 servers in the cluster, and somehow there becomes a split, maybe 3 of them are on one host and 2 are on another host.
Split brain, yes.
Do they figure out that if there's not a majority of them, that they may not be an active cluster? Or, I mean, how does that? So if you have a client that could still get to both of them, but for some reason, they can no longer communicate with each other.
So split brain is a very difficult problem to solve. So automatic recovery from split brain is a very difficult problem to solve because it's not only 2. What if you had 5 split brains?
Right.
Then which one's right, which one's wrong? So what we do is we let you know when split brain happens. So that you can then go ahead and if you What you can do is if you restart some of the nodes, they'll automatically join the others.
Okay.
But when the split, first of all, NCache has built-in resilience, so it doesn't cause the split brain until it has kind of worn off its retries of trying to reestablish. But it cannot wait too long, because the longer it waits, the longer it delays all the other operations. So it's a trade-off between high availability and so so split brain can happen. Most of the time it doesn't. If everything is within the same data center, the split brain is very unlikely. It happens more when you have multiple data centers, and that's where NCache has this bridge topology. If you want to have, so we say you have separate cache here, separate here, and the bridge can synchronize the caches across data centers. In which case there is no split brain, because the bridge knows that the sockets can break, and it'll queue up stuff and do conflict resolution.
You talked about read-through model. Is that can you shed some light on it quickly?
Sure. Let me just quickly. I think that's good. So the read-through essentially is your piece of code that actually runs on. So your code that runs on the cache cluster. Read-through, write-through, cache loader, cache updater, which I was talking about. And a read-through model is very simple.
Just quickly a follow-up question. Is that a feature specific to NCache?
Yes. In the .NET side, only NCache has it. On the Java side, there are other players that do have it. But on the .NET side, read-through is something that only NCache has. The options that you have on the .NET side, there's NCache and there's Redis. Redis is essentially it's a Linux-based cache. If you go to their website, redislabs.com, I mean it's a great cache. I've got it's very fast and but it's very simple. It's one of the reasons it's fast is because it doesn't have a lot of features, but it's all Linux based. They don't even
Go to Redis.io.
right. So what happens is that Microsoft Tech Group ported it to Windows. So the only Redis that you get on Windows is the unsupported one. Or if you're in Azure, you can get Redis as a service. When you get a cache as a service, then you don't have access to the cache cluster. So you are only seeing the API, and none of your stuff can run on the server. You don't even get to monitor the cluster. All that stuff that we just saw, where you can monitor what the capacity was. You are totally relying on Microsoft or on any third party. It doesn't have to be Microsoft to do it all for you. Most of our customers, as I said, are I mean, if your business application is not that sensitive, it's fine. But if your business application is more serious, then you want control over your stuff. So we've intentionally avoided the service model up until now, which is that we encourage you to do a VM model. So deploy NCache as part of your VM infrastructure. Even in Azure, you will get an I just showed you NCache, VMs, right? So we just did everything on VMs. So if you have an ASP.NET application running in Azure, it just becomes a client on some caching VMs. You have total control on those VMs. You can log into them, you can monitor them, you can add more VMs, you can see what the performance is, you can do benchmarking and see. I mean, a lot of the time when our customers, let's say your application is performing poorly for whatever reason, you don't know where the problem is because it starts from the application. There are a bunch of things in between all the way. So you want to know benchmarks of everything. So you want to get benchmarks of your application response time. Then at the same time, with the same time sequence, you want to correlate the caching layer. Then you want to also correlate the database or whatever other system you're using. So the more control you have, the better you'll be. At least if you have a more serious application. So that's why we did it that way. So NCache is a completely native .NET. Redis comes from a Linux background. Even Microsoft on Azure uses Redis on Linux. So, and that's, I mean, you don't see it because it's a cache as a service. So at this time, NCache is also open source, so it's not like if you don't have the money, you don't have to pay for it, as I said. But if the project is important, go with a more supported model.
Is it limited like one service stack?
It only has limitation in terms of features, not the number of instances that you can have. So if you were to come to our, for example, let me go to addition comparison. So, for example, you get the replicated cache, you get the partition cache. So the partition cache is unlimited. It just doesn't do replication of partition. If you want replication, you want to do this. It's got a lot of other features. It's a fully functional. It still has more features than Redis.
When I
Let me just say it that way.
Service Stack had a limit of in the free version that you can only do 6,000 requests per hour. And after that,
None of that. None of that.
the,
None of that. It's all based on your capacity. Thank you very much, guys, for your time. Appreciate it. Thank you.
Where is the App Fabric? Is still there?
App Fabric is actually going away next year in February. So if you are using it, you need to plan for alternative. NCache provides you a seamless migration. We have an App Fabric API wrapper, which is also open source. So you can move to it without almost any. I mean, you just need to change namespace and stuff, but everything else stays. Exactly. Same thing. Totally configuration based.
In the beginning of the lecture, you talked about this architecture for queuing and
yes.
Do you have any documentation?
Actually, if you come to our website, there's a lot of documentation on it, and also there's a talk that I gave on runtime data sharing, which talks specifically on it. Also, I wrote an article.
You don't have an application as critical as wires, but something similar.
I also wrote an article in MSDN magazine. Let me just actually, if I can find it. They've just restructured the website recently. There it is. Magazine. So I wrote an article a while ago called Runtime Data Sharing. It's an MSDN magazine. If you come to our website, you'll see it. So it talks in detail about how you will do it.
Basically goes across.
I assume it works like a lot of caching where you have one key that gets you access to your value, your payload, whatever you want that. Is there a way of putting alternate keys or something like that on these, or do I really
you can actually you can have tags. So the key becomes the primary key, and then you can have tags.
Okay.
So multiple items can have the same tag.
I can fetch by tag then.
You can fetch by tag, fetch by group.
Does that have performance impact?
No.
Okay.
No, it's pretty fast. It's the same. You may get multiple items back, or you may have multiple items at the same tag.
Okay.
They can if you want to, or you can give every item its own tag.
So we work a lot with Microsoft Dynamics CRM.
Right.
Fetching data through their APIs can be quite slow.
Right.
And we have a couple of things that we're doing now that needs to be higher performance. And I think that's great. Does the custom code we were talking about for the read-throughs and custom dependencies and those things, is that only available in enterprise?
Yes, it is. But again, work with our sales team. It's very affordable.
So the open source is SQL and Oracle, and then custom would be enterprise.
Yeah.
Okay. Cool. Super. Well, thank you very much.
Okay,
It's very
thank you very much. Thank you.
Okay. You had the first number is 3. Another 3. Another 3. 7. 5. 8. 9.
They should just say the numbers in no particular order, and you have to figure out if you have all the numbers.
Going 1. Going twice. It's done. So, the next one is 3,
I don't know where my orange ticket is.
7, 6, 0, 4.
Oh, does it have my name on it?
Name and phone number.
Oh my God. Fair enough.
You were standing in the wrong place.
Just looking at my blue ticket.
It is